Assalamu alaikum. Welcome back. This will be our lecture 3 of our course to EC253C microprocessors and microcontrollers. We will be starting. We will be again starting with our microprocessor design. What we have studied so far. We have studied that inside a microprocessor are three main parts. We have something known as ALU. Also we have a register array, that's a group of registers. And then there is control unit. Then this processor actually communicates with outside world. It actually communicates with RAM and ROM first, the internal memory inside a computer, while programs are stored, instructions are stored, RAM and ROM. And also communicates with input output ports, from where it gets the data and then sends the data as an output, manipulated that data as an output IO devices. And this is system bus, which actually consists of three types: data bus, address bus, and control bus. We have discussed these things. Maybe very briefly, but we have discussed each part, what exactly this is. The most important thing inside a computer is this processor, and the most important thing inside a microprocessor is arithmetic and logic unit. So let me try to explain what exactly this arithmetic and logic unit does. What are the arithmetic instructions that a processor needs to execute? What are the logical instructions that a processor needs to execute? What exactly we mean by the instruction set? That's an important term. Instruction set of a processor. One thing you should keep in mind, when I say processor, I mean both microprocessors and microcontrollers, because microcontrollers are nothing, they are processors with some added things in it. So when I discuss processors, when I say processors, uh, that also includes microcontrollers. They also have all these things. So what's the basic thing a processor is supposed to do? Processor is basically supposed to do some operations on the data. And what are these operations that can be done on the data by a particular processor? That is actually decided by the processor design team. The ones who have designed the processor, they decide which operations this processor can do and which operations this processor cannot do, one thing. And second thing, they also decide on which data these operations can be done and on which data these operations cannot be done. So some processors like 8085 processor, which actually we are going to study in our course, I have already told you that the oldest processor made by Intel. So I was saying that some processors which are actually very simple, they have some very basic operations and they are satisfied in doing that only. Like 8085, it only has it may have addition and subtraction, it doesn't have a multiplication, for example. It doesn't support multiplication. But other processors like 8086, they may support multiplication but not some other complex functions, some other complex arithmetic functions. Some processors even do square roots. Even division is supported by some of the processors. So basically, what exactly the number of instructions, the number of different arithmetic and logic instructions, and the data on which they may be done actually constitute the instruction set of a processor. And again, apart from these arithmetic operations, a microprocessor is required that it may do some logical operations like and or, some basic logical operations and or, XOR, and some shift operations like shift left and shift right on the data. So again, I will repeat: the number and type of operations actually define the microprocessor instruction set. The microprocessor instruction set is actually the number of operations and type of operation, and on what data these operations can be done by the microprocessor. Next, let us briefly look how exactly an instruction is executed by the processor. Instruction execution. Execution usually has three phases. Let us say we have this memory, and somehow we have not gone in those details how exactly a program is burned. We call it to burn the program, to write the program instruction, write the program that actually consists of instruction inside the memory. So let us assume for the moment that the program has already been written inside the processor. There's an instruction, there are a lot of instructions that have to do a particular job, and these instructions, any job by a microprocessor will actually consist of the instructions from this instruction set, because this processor only recognizes instructions inside this instruction set. So how these instructions are executed? One by one, each instruction is taken by the processor while it is decoded and then executed. So instruction execution is actually a three-step process, and there are three technical names for it. The first is instruction fetch. The second step is instruction decoding. And the third step is instruction execution. The first step, the reading of the instructions from the memory by the processor, is known as instruction fetch. Fetching of the instruction from memory from memory inside the processor, and inside the processor there may be a special register that temporarily holds this instruction before it is actually decoded by the decoding circuitry. Once the instruction has been fetched, then the instruction has to be understood, like what the instruction means, what the processor has to do. So this is called the decode stage, and after the decode stage has been done, the processor knows like what is the operation, and after this instruction is decoded, the instruction is actually executed by the functional modules, adders, subtractors present inside the microprocessor. So far, what we have studied, the internal architecture of a processor here, and also maybe how an instruction is executed and what exactly is an instruction set. Every process is like this only, but this is only a bird's eye view of the whole system. There may be arithmetic logic unit, maybe a complex circuit, register arrays, we don't know what they are, why exactly they are there, what exactly is the control unit, is there any other part inside a processor, and then the instruction set we have not also got into it deeply, and then these phases of executing an instruction: fetch, decode, and execution. They may not be as simple as that. There may be sub stages. So basically the lecture so far, or the topic so far, was actually to give you that bird's eye view only about the whole system, about the functioning of the whole microprocessor. Now we are going to study, now we are going to take one of the microprocessors, 8085. 8085. As I have already said a couple of times, it's the oldest microprocessor made by Intel. And one of the questions may be, why we have to study such an old microprocessor. A simple answer, there may be a couple of reasons. First, it's very easy to understand 8085. Once you have understood 8085, at least for first few lectures, and then you may study other advanced microprocessors and microcontrollers first thing. And then another thing is that the modern microprocessors, they are actually somehow built around the basic structure, basic functioning of this 8085 microprocessor. There were other some early microcontrollers like 8088, 8088, or somewhere from Motorola 6800, or there was Motorola 68000. Then we also had one more from Intel, 8086. 8086. The 8085 we are going to study, and also this 8088 and 6800. These are all 8-bit microprocessors. I have already explained what exactly we mean by an 8-bit microprocessor, that our arithmetic and logic unit will actually, the instructions it will be doing will actually be in on 8-bit data only. It will be, if it is having an add instruction, it will add only 8-bit 8-bit operands, 8-bit data. If the data is larger than 8 bits, that has to be broken by the programmer. Okay. And similarly, the most of its registers will be 8-bit. Its functional units inside adders, subtractors, that will be 8-bit. But these these microprocessors, 8086 and 68000, they were 16-bit microprocessors. Modern microprocessors may be 32-bit or 64-bit also. So let's briefly start with 8085. With it's there are many things we have to study. I've already told you that we have to study about the architecture of this processor. What exactly is ALU, register arrays, control units, and then how it communicates with memory and IO devices. First thing, we have to study our microprocessors. The second thing is about its programming. What are these instructions? What is the instruction set? And how we write how we write a program out of these instructions that are provided in the instruction set, and then how these instructions are executed. What are these phases: fetch, decode, and execution? How things happen inside a microprocessor. Let me start with its programming part. Let me start with its machine language part. So first of all, it's an 8-bit register. We know that by now, 8-bit microprocessor. And also there's another thing you may want to know. It actually can handle 64 kilobytes of memory. That means we can attach a maximum of 64 kilobytes of memory to it. This is the memory, and a maximum of only 64 kilobytes of memory can be attached. Why is it so? Why not 128 kilobytes? Why not more than 64 kilobytes? What decides how much memory, how much maximum memory we can attach to a processor? I have already told you that before reading a memory, here we have memory. This is our memory. and this is our processor. Or let me draw the memory like this. This might be my memory. Okay, so inside the memory we have different memory locations. And our memory is actually addressed using the names of these memory locations. So these the names of these locations maybe like this: 0, 1, 2, and so on, maybe 36, 37 different memory locations. And each memory location may be a byte long or maybe 2 bytes. In most of the cases we call it byte addressable memory. So each memory location is actually 1 byte long, so 8 bits, 1 byte. This memory may be very long, so this memory is only 37 bytes, or if it's very long it may be 370 bytes, or it may be 3700 bytes or 3700 bytes. Okay, now when our processor wants to read anything from this memory, what it does through the bus, we have a bus here. Buses are actually lines, physical lines, wires, set of parallel wires. And this bus actually consists of address bus and data bus. Let's discuss here address bus. When our processor wants to read any of the memory locations, it actually sends the address of that bus, address of that memory location, using this address bus, using these lines. And this address bus, this again can be 8 bits wide, and this can be 16 bits wide, or even 4 bits or 1 bit wide. If this address bus, for example, is only 1 bit wide, I have a case like this. I have a processor, and then I have memory, but there are different locations, and then I have a data address bus that's only 1 bit wide. So how many different memory locations can I read from using this? How many different memory locations can actually I address using this 1 bit wide address bus? Only 2 memory locations. I can either put 0 on this address bus. In that case it will read one particular memory location, maybe this, and I can put 1 on this address bus. My processor can put 1 on this address bus, and in that case it will read another this next memory location. But if this address bus is 2 bit long, so I can read 4 different memory locations. I can read memory location 0, I can read memory location 1, I can read memory location 2 also, I can read memory location 3 also, depending on the value I put on this address bus. And then I have to read data also. Since I am reading the data parallelly, I can only read 2 bits of data. So in my processor, since it's capable of handling 8085, it's capable of handling 8 bits of data. So this bus, the data bus actually, the data back will be sent using data bus. So this data bus should at least be 8 bits wide, so that 8-bit data comes from the memory to the processor, or is sent back from processor to the memory. Because in the 8-bit it has to process data, it can process data up to 8 bits, and if address bus is less than that, then that is actually a bottleneck. One thing. Second thing, but in case of 8085, this address bus is actually 16 bits long. This is my processor, and this is my memory. This is my processor, and this here my address bus is actually 16 bits long. One thing. And then there is inside register array, there's a special register which actually puts the data on this address bus, which actually decides which instruction from where to read the memory next. So that register also needs to be 16 bits long, because that actually holds the address of the memory location that needs to be read. So there's a register inside that's 16 bits long. That register holds the data from where we can read, from where we need to read the data, and then this 16-bit address is actually put on 16-bit memory location, and depending upon the combination of zeros and ones, we get a particular memory location from which the data is to be read. So since this address bus is 16 bits long, we can actually address 2 raised to power 16 different memory locations. And since each memory location is equal to 1 byte, then we can address 2 raised to power 16 bytes. That actually can be 2 raised to power 6 into 2 raised to power 10 bytes. 2 raised to power 6 is 64, 10 is kilobytes. That's why we say that 8085 processor can have a maximum of 64 kilobytes, because its address bus is 16 bits long, and the register, we have not named this register yet, but there's a special name, and this register inside the processor, that is also 16 bits wide, so it can address a maximum of 2 raised to power 16 different memory locations, that is 64 kilobytes. This is one thing. I think we should stop here today. We will be discussing more about 8085 microprocessor in our next class. Okay, thank you. That was all about lecture 3.